Hi everybody, I'm Scott Allen Miller. Today on Sam IT, we're going to look at what is DNS. DNS is the domain name system, and a long time ago, this was devised to make it easy to have a global infrastructure for looking up the names of services on the internet or other large TCP/IP based network. The idea behind DNS is pretty simple. You need to look things up, like with white pages or yellow pages, and you can't put everything into a host file. If you're not familiar with host files, you can watch the video that we just posted about how host files work. But you need it to be maintained for you, and you want it to be globally up to date, and the same thing that everyone else sees. This is where DNS comes from. We're not going to dig into a lot of the really heavy technical stuff about DNS, about like, you know, it uses port 53 on UDP, but why, and you know, we're not going to go too much into that. It's pretty basic, and everyone uses DNS all the time. And you can host your own DNS servers, or you can use public ones. You can use lots of different ones. In theory, they all point to the same places eventually. Some are just faster, and you can have some security or other features delivered through DNS, and we're not going to dig into all those details. DNS can do some interesting things, but the basics of DNS are very simple. Basically, it is a large set of lookup tables, just managed by large databases, because typically you want the entire internet available to you, not just the things that you can learn ahead of time and put into a text file. So when you're looking up DNS entries, the way that it works is that your computer is pre-set up to have DNS servers that it looks to. The most common ones are Google's today, and people know them as 8.8.8.8 and 8.8.4.4. There are many others out there, but Google has kind of taken the title as the DNS leader, and they do a great job with that today, so commonly that's who you would use. Your system is configured with these. You can go onto your system, whether you're on Windows or Linux or whatever, and look up your network settings, and you will see your DNS entries in there. You could have more than two. Typically people do two, however. And when you go to do a lookup, and lookups happen anytime you put in the name of a resource on the internet. So this could be whether you're going to the NS lookup command on the command line, or you're putting in a URL into your web browser, or anything else. And lots of your applications under the hood are using things that you just don't know about or don't notice. They look up a name, such as www.google.com. Your system will go to 8.8.8.8, because that's what you have configured as your DNS server. It will send a request that says, I'm looking for www.google.com, and then hopefully the system that it's talking to, the DNS server, will have that entry somewhere in its database. It will look up what IP address should be associated with that URL, that host name, and it will send it back to your computer. Your computer will always contact resources by IP address. It can't just say, I'm going to www.google.com and magically get there. That doesn't mean anything to the routers and switches along the path. But going to the IP address does. And so getting that IP address is critical for your computer to do anything, and the only way it's going to get those addresses is through a system like DNS, or if you use IP addresses directly, or if you put them in ahead of time into a system like host files. DNS has been around a long time, and it uses a hierarchy of servers so that the Google server, for example, that you may hit first at 8.8.8.8, doesn't have to necessarily know where every server in the world is. It has a set of root hints, as they're called, that it knows where to go looking for additional information that it may not have itself. There are authoritative DNS servers out there, and it, as a DNS server, knows how to find them. I'm not going to dig into all those complexities here. I want to keep it simple that you, as an end user using DNS, it is rather simplistic, and one of the biggest mistakes that's made with DNS, one of the things that makes it difficult to use, is that people assume it's a lot more complex than it actually is. It is not. It is extremely simple. Now, there are multiple record types in DNS. The one that we talk about all the time is known as an A record. These are just the normal everyday lookups where you give it a name that you want, and it gives you back an IP address to go use. There's also what's known as a pointer record, or a PTR record. These are also known as reverse lookup network records. These work exactly the opposite. Instead of you giving it a host name and receiving an IP address, you send to the DNS server the IP address, and it gives you back a host name. All the more there is to it. There's also an MX record, which is the record you use when you're requesting information about where to send email using a specific domain name. So if you're looking for google.com and you want to send an email to there, you would do an MX record lookup, and your DNS server will return the name of the email server specifically that you're looking for. That would be a mail exchange record, but everyone just refers to them as MX. Of course, you can hold other record types in DNS, but these three represent basically all that we ever use in the common space. If you run your own DNS server, you can make up your own record types. I wouldn't recommend that. There are some record types that are used for security, like SPF, but they've kind of fallen away. And there are other record types like the TXT or text record field, where you can put in arbitrary information to store kind of anything you want in DNS, which is not very useful too much in the public space, but could be very useful if you're running your own DNS servers internally. You can use it kind of as a public lookup database, but you want to limit the use of that to some degree. DNS isn't really designed around that, but it does work. So it is an option for certain types of things. But by and large, you need to be aware of your A records, where you look up the host name to receive an IP address, PTR records, where you're looking up an IP address to receive a host name, and your MX records, where you're looking up the name of an email server. And of course, an MX record would then, when you look it up, it would return the host name. You then need to do another call to look up the IP address of that host name. So it's a two-step process to get to where you need to be. The last record that's worth noting is what's known as a CNAME, also known as a canonical name, or a alias. These function like A records, and when you use them as the end user looking something up, you would never know you're hitting a CNAME, but it allows the person who's working with DNS to point one name to another host name, one host name to another host name, that then gets looked up through its A record. It just makes it easier to have multiple things that point to one. So for example, you might have google.com and www.google.com and web.google.com, and you may only set the IP address and the A record for google.com, but you may have www.google.com and web.google.com be CNAMEs that simply point to google.com. That way, should you need to change it because you got a new server, for example, or your IP address changed, you only have to change it in one place, and all the others are aliases pointing to the first one. Aliases are handy abstractions. That is the fundamentals of how DNS works for you. You ask it what you need, it returns the IP address. There's nothing more complex than that. Some people believe that they can get port information, layer 4 information returned by DNS. This is incorrect. It does not work that way. It works on layer 3. You give it a host name, it returns an IP address. It doesn't give you more information than that. And it cannot be reconfigured to do so. That is not within the protocol specs. DNS is one of the most handy things you will use, and understanding how it works and when it comes into play, which is nearly all the time, is very important, because a tremendous amount of troubleshooting and problem solving within IT requires you to understand what DNS is doing, understand how to check it, and to do so quickly, because by knowing if your DNS is working as you expect tells you an awful lot about why other things may or may not be working on your network. Thanks for joining me. Remember to like and subscribe. We will dig more into name services and other things related to DNS in future videos. And remember, as always, you can sponsor us on Patreon, where just a little bit of sponsorship from you can show how much you appreciate this show and help sponsor us to make sure that we're able to continue to bring you more of these educational videos in the future. Talkadillo is a cloud-hosted or fully managed on-premises IP PBX platform providing businesses with simple and simply affordable voice communications. Visit Talkadillo.com and learn more about how Talkadillo can change how you view your telephones and help to support SAM IT.